Okay, so let's review a little bit about what we learned on this day. Element of high quality program. Right? So in that we learned about before program. Right? The first step is to declare whatever it is, that whatever is the variable you use and constant you use here, right? And you have the two type constant. You have the numeric constant and have string constant. And also when working with variable, try to use meaningful variable name, right? Okay, and also in the for the numeric for the variable also we have the numeric variable or string variable. Basically, that when you work with pseudocode, you need to declare num for the numeric number variable, and we have the string for the string variable. And okay, have the sum of the syntax for the variable. Remember that variable name, they are case sensitive, right? Okay, so uppercase and lowercase is not the same. Okay, and you have the sum of the convention, right? So when you're assigning value to a variable, remember that for whenever we want to assigning value to a variable, we have set the variable on the left and you assign value with on the right, right? And so basically for this kind of operation, they will do everything on the right first and figure out what is the number, what is the validity, and you assign back to the variable on the left here. Okay, and some case you want some case you can declare and you can initialize the variable at the same time. And so for the constant, right, try to avoid a magic number. Think about in the case of the state of the tag rate here. You know that is 0.06, but instead of using the magic number, it's an unnamed constant 0.006 here. It's very hard for user to follow up what going on, right? So it should be better you put the cell tag amount. It is a constant name, and they put it at the beginning of the program, and it assign it to the value of 0.06. Okay.
Filter in place, bro.
Thank you. Okay. And you have the perform. You have shelter? Okay. So it has stay inside, right? Yeah. And it has a turn of the light on what?
I don't know.
Okay.
Sure.
In the case of the track, Alan, we have to turn off the light. But I think it's not. Also, we learn about the rule of the priority. We learn something about this one. Integer data, and remainder operator. Okay, we learn about the modularization. Right? So in the case you have very complicated program, you should break it down into multiple modules, and you have many benefits of the when you break it down into the module here. You see, program is easier to read, easier to design, code, and test program one module at a time. And different program module can be designed and coded by different programmers. A single module can be used more than one place in the program. Also, it can be used more than one time in another program, also, right? Okay, and also you learn something about global variable and local variable. Okay, now the most important concept in the module 2 here is that I want you to understand about the main line logic here. So basically, the main line logic of every procedural program here, right? You have the step of declaration for global variable and constant at the beginning of the program outside of any module, right? Now, for the housekeeping task, it is step you must perform at the beginning of the program in order to get ready for the rest of the program. And I give you the multiple example with that one, right? That is a step, normally it's a step you have to do at the beginning of the program to get ready for the rest of the program. And you remember that when we work with the housekeeping, it must be done outside the loop and before the loop, right? So when you get the housekeeping task here, you ready for the rest of the program, you go to the detail loop. That means in the case you do it again and again and again, huh? And When you're done with the loop, you have to add a job task here. So you see, in that it's very simple example here, right? You can think about that case you want to access into the payroll report here, report here, right? You have take it out what's the name and take it out what's the gross, right? So from that you can figure it out what's the deduction, and from that you can find out what is the net income here, right? So we think about this one. You have in your company you have many employees, right? So you have to do it in the process from the first one to the second one to the third one and the fourth one and so on until the end of the report here, right? So that's why you see you have the housekeeping here. Housekeeping, you keep doing it. If not end of file, EOF here is not end of file. Just keep doing it to every single employee on the report here. So we can do the same. That is a specific example. In the mainline logic here, you see you have the housekeeping, and now for each of them you have to check the name. If the name is not equal to quit here, you see. And if you look on the coding for this one, you see you have the declaration at the beginning here. You have declaration at the beginning here. You see this one is constant right here, right? And this one also is a constant. It is string format. This one is a number format here. Right? So see now the housekeeping here. If you look on this one, that it is a module. I see whenever you see in the flowchart, right? And you have the rectangle with the bar here. It is a module. Right? So see when you run with the module, when the program executes the module, it stops from the main program. It jumps into the module. It look at what is the housekeeping here, right? And execute everything from the first statement to the last statement inside the module housekeeping here. And so basically that is the report of that is a print out output. But the more important thing in that step here, you have to get the name. What is it? Name here is the name of the first employee, right? And you really need it. You really need it in order to maintain the loop here, right? Because see, when you got the name here, you go to the loop, you have the action to check if name equal to the act or not, right? See, if you do not get the name here, you got the syntax from here, right? You not understand anything here. That's why housekeeping is very important, and it is a step to get ready to the rest of program here. And remember, it is outside the loop here and before the loop, right? So now we see again when you go to the loop, you check if the name is not I keep doing it with the module name detail loop here. What's the detail loop? See, you take out the gross, right? And figure it out what's the deduct, and from the deduct you figure out what's the net income, and you print it out, name, gross, deduct, and net income. Now, if you want to move on to the next employee, you have to get the name of the next employee here, right? Okay, so the process, that's the process here. That's the process of the mainline logic, and I hope you really understand about the process here. And you see, it translates the same from the flowchart to the pseudocode here. Everything here, it is a declaration. Housekeeping here, what is it? When you call the module housekeeping, it jumps to housekeeping here. And the more important step here, you take the name of the first employee. So now, when you're done with the housekeeping, you go to the return. Return, that means you move back to the main program, you jump into next statement. Next statement here, check if the name you got it from here equal to quit, it's act here or not, right? If not, keep doing with the detail loop. What's the detail loop? Again, it's jump into the detail loop here. Take it out, gross, right? Figure it out. What the deduct? Figure it out. What is the net income? Print it out. Right? Print it out here. Right? And now see, you need to get the name of the next employee here. Right? That's the process. That's the process. So once you understand this process, it's very helpful for you to work with the debugging exercise. Not only on this module, but on the next coming module. What am I supposed to do with this one?
I think it just means it's over.
Okay, so in the case that you work with a modularization, right? That means you break it down into multiple modules here. So in the step of planning, it's very helpful if you work with a hierarchy chart here. And hierarchy chart is that show you what the connection, what is the relation between the module, right? So if you look on this one, you can see you have the main program, and in that you break it down into 3 modules here. You have the housekeeping, you have detail loop, and you have end of job here. And again, for each module, again, you can break it down furthermore, right? So if you think about it, very complicated program, you can take it down furthermore, and so on here. Okay, now you have the summary picture of the good program design, right? Use program commands. It's very helpful. In the case you have very long coding, or you have very complicated programming, it's very helpful for you and for other one to follow up what's going on with your coding here. All right. See, use program command where appropriate. Identify should be choose carefully. That means the variable name. Right? Should use it very meaningful variable name here. Try to design a clear statement within the program and module, right? Clear prompt and echo input. Prompt is that means they tell user what they are supposed to do, right? And the echo input, that means you bring some of the variable from the input, you take it out in the prompt here. I give you some example already, right? Okay, now program command. Program command is a written explanation of the programming. A statement is not part of the program logic. So basically, for whenever you write the command, when the program executes it, it will ignore every command. Right? So from the computer point of view, you have no benefit, but it has a huge benefit in the case you are the programmer here. Okay, so in some case it's very complicated. You can use a flowchart to see the relation between the module here. Okay, that is a comment. You can think about it. You can include the comment in the flowchart, or you can do the same in the router, right? And choosing the identifier, that means the variable name. Try to use it very meaningful name for the both of the variable and module. So, okay, and in some case you have to use a temporary variable to make it to clarify the long statement here. I think about this one here, right? In that case, instead of using the long operation here, you can use 2 more temporary variable name here. Prompt is very important, right? Prompt is very important here. It's a message display on the monitor to ask user for the response, right? Also, you use both in the command line and graphical user interface. Also, in some case, you should use the echo input to make it more sense. Okay, now the prompt, think about this one here, right? So see, in the first example here, you have the declaration and you get the input and stored in the name and stored in the balance here, right? So I believe I will give you the example of this one here. Think about this one here. Where am I? Okay, let's see. The K raptor here, right? So in the K raptor here, you can think about this one. I start again. And I want to find out what is the assignment here. I want to find types, like type 2 here. Right? I just want to double the number, and I want to print it out. What is the number now? I have idea. Right? So see, when I run it here, you see it's the input here, right? For this one, I do not have any problem. I do not have the prompt. So think about if you are the end user, you are not a programmer here. The answer very hard for you to understand what's going on. So it should be better. You have to put some of the prompt here to tell the user that what is supposed to do here, right? So we think about that case, you have to make it here. You have to make it use the prompt here. Please enter the number. So now for this one, you see, I have entered the number 10 and my output here, number 20. Again, you see, in the 20 here, it not really makes sense. Okay, right? So I can modify it here to make it more clear by include the the double. Okay. Okay. So see, enter the number 10 again. I have the double here. Oh, I not set it here. Okay. So that is the case. You use the prompt, right? That in the case if you want to use the echoing input also, right? So see, in the case I can modify it here. The double this one should be better. I use it another variable here. Right? The double of 10 is white. I think for this one, I enter the number 10 and I have the double of 10 is a 20 here, right? So it makes a little bit more sense. I see that is the echo input that I take it out from the input and I take it a part of the prompt in the output here, right? Okay, so now come back to the slide here. Right? So basically, you can see if you work with a flowchart and the pseudocode here, you have step input. That means you got it from the user, right? And you store it into the variable name and balance here. Right? But now in the case if you want to increase, in the case if you want to include prompt here, you see whenever you include the prompt, you have to tell user what they have to do here, right? So see, whenever you have the input here, you have the output before that. The output here it is the prompt to tell user what you have to do here. Right? So basically, see, whenever you have the output, please enter the customer name. It's the prompt display on the screen. But after this one here, so what happens is, you see, or this one, what happened with this process here? What happened with this process here is that, see, if you have the prompt on the screen, and please enter customer name, right? So if I enter the A here. So what happened if the user enters A? The action here is that you have the slot in the memory, it's a name, right? It's a name, and it stores the value A into the slot memory, it's a name here, right? And the same, if you enter the number 1000 here, again, you have the slot in the memory with the name is the balance, and it stores the number 1000 here into the reference name here, right? Again, remember that in some of the debugging exercise, you have to understand the process of the prompt. This is the prompt here. This is the prompt, right? And this is the process store value into the variable name. Right? In some case, you only have a prompt, or in some case, you only have the process to store it in variable name. You have to find out what's wrong with your coding. Okay, that is the case here, right? So that's the case also. That is use the echoing input here, right? Please enter balance due for name. You got it from the what you got input here, right? To make it more sense. Okay, now maintaining the good programming habits. Every program you write will be better if you plan it before. Now, even that very simple program should be better if you plan it before. And maintain the habit of first drawing flowchart or writing pseudocode. That check your program logic on paper. Think carefully about the variable and module name, and design the program statement to easy to read and use here. So basically, that's all for the slide for this week. But again, I strongly recommend you that you have to come back and you have to totally understand what the logic of mainline logic here. You see it again and again in this class, not only on this module. Now I come with some of the Python here. The Python. So basically, I look in the homework assignment for this week. You have 3 Python assignments. You have the 3 Python assignments. So basically, when you work with the Python or whatever program it is, the process is quite the same. The variable is a variable that the name represents the storage location. It's the same, right? And it's changeable, right? And you can use the assignment statement to create a variable and make it reference as a piece of data. Variables are reusable, right? And when you want to concatenate the string and number, you use string built-in function here. Built-in that means you do not have to define it. You just use it here. So basically, in the Python, I think about if you run the Python program here, as of here. Think about if I had put y equal to x plus 10 here. So what happened with this one? If I put the y equal to x plus 10, I hit the enter. What happened? What do you say? What will happen here?
Syntax error.
Yeah, it has syntax error, right? You won't have the syntax error. And why you have the syntax error here?
X isn't defined.
Yeah, right. So the thing is that in every assignment here, that you see in every assignment again, it do exactly the same. It execute everything from the right, right? Sorry, I think it should be it's executing everything on the right, and it assigns that value to the variable name on the left here. So basically, for this one here, when I put y equal to x plus 10 here, so basically in the computer, it try to locate what is the x here. So basically, it expects that you have the slot memory with the name x and you have some value here, right? But for this one, I have not done anything with the declare or assign any value to the x yet. That's why you have the syntax error. You see, x is not defined here, right? So now in that case, I can do it, right? In that case, I can do it. I can assign it here. I can assign it right equal to 10 here. Now I can put y equal to x plus 10. So we have y is the 20 here, right? So the process is exactly the same. The process is the same here, right? So what happened here? For this one here, that means after this step in the memory slot with the name x, I have the number 10. Now, so what's the y equal to x? What is the x? Take it out number 10. Take it out number 10. Plus it's 10. I have the 20. I have value 20. And I assign it to the value y. That means I have another slot in the memory with the name the y. I store the value 20 here. So now the last one, I take it out y and bring it out. I have 20. So basically, when work the Python, you can directly assign the value to the variable, or you can get it from any user. So in the case, you remember that on the module 1, whenever you want to get it from the end user, you use the input function. You use the input function. Again, it's a built-in function. You do not have to define it here. So think about I have x equal to input here, and I have the prompt here, right? I use the prompt here and a number. Sorry. So I put the number 10 here. Now I put y equal to x plus 10. What happened here? What happened here? If I hit the enter,
20.
Sorry,
20.
You said 20.
is that correct? If I enter the x, y equal to x plus 10, what happened here? I mentioned it on the module 1 already. What happened? What do you think? What will happen if I enter y equal to x plus 10 after this step here? What happened? What will happen?
You get a syntax
Yeah, you got the syntax error, right? Why?
because you have to convert it.
Yes. The thing is that whenever you got the input function here by the default, it always is string format. Right? Always string format here. Right? You see for this one here. I hit enter. See, you have the syntax error because actually the number 10 here you enter. Actually, it is in string format. That means he put it here. Sorry. That means it is under the quote mark here. Right? And of course, you cannot add string with the number. Right? So basically, in order to do that, you have to convert the string of 10 here into the number, into the number 10. Make sense? Okay. Yes, that's what I mentioned in the module 1 already. So for this one here, see, you can have yeah. Now you can correct it here, right? So we think about this one. I print it out again. What happened here? See, that is string. That's string here, not a number. Now I can do it. I can do it here. I can convert it again. I can use a built-in function, integer function here. All right. So now what happened here? I print x again. Now it is a number. Right? Now it's a number. So see, I can put it here. Y equal to the x plus 10. So I put y here. Now 20. Right? Make sense? Okay. So basically, you see, that is the way you work with the Python and you assign value to variable. You can directly assign the value to variable, or you can get it from the user, right, from the input. But remember that whenever you got it from input, it always by the default, it always string format, right? And if you want to use it in any mathematical operation, adding, subtracting, or whatever it is, you have to convert it into the number format. And again, you have two functions. You have two built-in functions in the Python. The first one is the int here. Int function, and you put x here, right? It converts it into integer format. Right? So it enters the number 10, it converts it to 10. Or the second one, you have a float here. Float you use when you work with the decimal number, the 10.5 or 10.65, whatever it is. Right? Okay. And in some case, it should be better that you use both of the combination of both the two functions at the time. You think about this one here. I have the I equal to input here. Sorry, input. And float number. Now see, this one is I got it in string format, right? If I want to convert it in floating point number, I use a function here, float here. Right? So see, I use a combination of both of the function at one time. So see, this time I put the 10.75 here. Now I print it out x in the number format already. Right? Okay. So I think that is I think that's all you need for the Python exercise for this week. And anyway, let's see what is the best one with the Python. Okay. So for this, for whenever we work with the Python, yeah, again, my suggestion here, you have to read instruction on the left, right? So we see what's the requirement here. So this in this lab you assign a variable in the Python program. The program will set in the file and calculate your age in the year 2050 here. Right? So basically, you see, if you see on this program here, the purpose is that find out what is your age in the year of the 2050. Right? So we see my new age here is my current age plus the 2050 minus my minus current year here. Right? So now, if you run this program, what happened? What happened when you run this program now? What do you think? What happened? The same process here. What happened if you run program right now? What happened if you run program right now?
You will have error.
What type of error? What type of error?
My code is not definite.
You have the syntax error, right? And why you have the syntax error? Why? You have not defined what the current year. My current year, age year, right? And you have not defined what the current year, right? Okay. If you want to use variable in your operation, at least you have to define and you have to assign some value to it, right? So see, if you run this one here, you see, name error here. My current age is not defined, right? And again, what was it? My current age here not defined here, right? So now, you see, instruction here, you have to assign an integer variable name, my current age with your current age in here. Right? So how we do it? You just write down my current age equal to 30 or 40 or whatever it is. Right? That's the first step. The second one here, you assign the integer number variable current year. Current year you put is a 20 year. Right? That's all. After this step, you can run it and it brings it down here. Make sense? Okay. Now about the second one. About the second one. You complete the version with the retail brand, wholesale brand, green, wholesale. Okay. Now, the program, right? Partially written in program, provide along with the data file this book, program written for the future furniture company, brings the name of furniture item, retail price, wholesale price, profits made from the future. Instruction here. Okay, the file profit here. Design a logic that calculates the profit. So see for this one here. For this one, you write the statement here for the profit, sale price, and the sale profit. So for this one program here, you see you have the three input, right? You have the item name, you have retail price, and you have the sale price, right? And this program requires you have to find out what the profit, right? What is the profit? What is the sale price after retail price and sale price? What is sale price? 25% here, deduct from the retail price, right? 25% deduct from, and you have to calculate the profit when the sale price and the profit it is okay. Now you can do step by step here. The first one, you have to calculate the profit at the retail price minus the wholesale price, right? You do it very simple, right? So you can write it down the profit, and you assign it to the retail price minus the wholesale price, right? Now you have to calculate for the sale price at a 25% deduct from retail price. So you can find it out, right? Okay, and later on when have to calculate the sale profit you have the sale price minus the wholesale price here. And you can try it here. So basically here you have to write down, write down the assignment statement to find out what is the profit. And you see profit is from the price minus the wholesale price. And you have to find out what's the sale price. Sale price, it is a 25% deduct from the retail price here. And later on you find out the sale profit. Do you think you have any trouble or any challenge with this one? It's quite simple, right? Okay. And anyway, if you need any help from this one, let me know. But I think it's very simple. So once you understand the structure, so when you understand the logic, it's very helpful. Again, in the module one, I also mentioned about the print function already, right? Print that whenever we want to print it out, you use the print function. And in that case, you can use a string here, and you have the item name here. I see. In that case, you can see it here. The item name here, it is string format. You put it under the double quote marks. That's why you can concatenate them together. But the thing here, retail price, it is in the number format. So that's why if you want to concatenate them together by the plot here, you have to convert this one into the string format by the string function here. Make sense? Okay? Yeah, makes sense here. Now think about this one here. Think about you have in the program here. You had IH 40 here. Think about that one. I can print it out. Okay, so see, with this one, I got the syntax error, right? I got the syntax error here because you see, this one here is in the number format, and if I want to concatenate it with the string here, you see, it print out here, can only concatenate string, right? Not the integer number, right? So in order to do that, I have to convert my h in the number format into the string format. So in that case, I use the built-in function. I use the built-in function here. I use the built-in function. It is a string function here. So after that, it will convert it into the string format. So basically, what happened with this one here? What happened with this one? It will convert my 40 into the string format 40 here. And of course, after that, you can concatenate them together. Okay. So that's the second thing about the Python I want to mention about. So basically everything about assignment, about getting input from user, how to convert it to the number format, and how to concatenate them together. Right? And what's the third one? Okay, so for this program, you have input already, right? You have the salary already, and you have the number dependent, right? So from that, you see, if you print the state tag and string state tags here, you will got the syntax error, right? Because state tag here, the program doesn't understand what is state tag, right? So that's why you have to find out what's state tag here, and it's that's here. You see, you have to find out state tag from calculate the state withholding at the 6.5%, and have to calculate the federal withholding tax. It's a federal tax. It's a 28%. So what's it? Federal tax, state tax. Okay. So now you see, you have to do your work here, right? The first step, you have to find out what state tax. The second step, you have to find out what the federal tax, and you have to find out dependent deduction here. You have to find out deduction is a 2.75%, as well as 2.5% and 2.7 for each of them. So okay, this one is the process of everything about the assignment, everything about calculation with the variable. It's very simple now. Now this one here, one more thing about this one here. In this program, the variable name, salary, and the number of dependent are initialized with the value of the 12 and 50 and 2 here, right? To make program more flexible, modify it to accept interactive input for salary and number of dependent. So how we do it? Actually, you have to get input from user, right? So instead of fixed to the 1,250 here, you have the option to get it from user. And of course, in that case, you use the input function here, and you have to convert into the floating point number, right? So you got the number of dependent here, number of dependent, you convert it into the integer number. Right? Okay. Any question about all the Python assignment? Let me know. Any question? It's quite simple, right? Okay. So now, if you have no question, let me move on with the universal markup language. That is the case in the, it's very helpful in the case you work with planning and step. So you have to write down the chart and to show what is the relation between the module or whatever it is this one here. So basically you have many types of universal markup language. And in this class, we focus on the case diagram here. So in the case diagrams, you can have the video diagram. Okay, I think it's in the discussion here. Okay, so the first step you have to discuss what is the universal markup language in your word. So you have some of the reference here. You have some reference. Okay. You have to use what is the display diagram.
There's no audio for the Zoom, I'm pretty sure.
They're completely lost. And
There we
I'll
go.
be teaching you everything you need to know about UML use case diagrams. We'll start with a high-level overview, then we'll talk about systems, actors, use cases, and relationships. And finally, we'll build an entire use case diagram together and go over examples to explain these concepts in depth. Have you ever had an idea that makes perfect sense in your head, but when you try to explain it to someone else, they're completely lost? Maybe your idea is for a new app, and every time you talk about it, people don't really understand how they'd interact with the app or what it would do. This type of scenario is where a use case diagram is very helpful. Here's a simple description of a use case diagram. First, it shows a system or application. Then it shows the people, organizations, or other systems that interact with it. And finally, it shows a basic flow of what the system or application does. It's a very high-level diagram and typically won't show a lot of detail, but it's a great way to communicate complex ideas in a fairly basic way. Before we really get into the tutorial, let's talk about how you're going to make a use case diagram. You can draw them out with pen and paper, but a diagramming application is going to be much easier. Today I'll be using Lucidchart, and you can too, for free actually. Just click the link to access Lucidchart's website. Enter your email address and you'll have a free Lucidchart account in just a few seconds. It's easy to use and you can follow along with me as we build a use case diagram. Okay, so we're going to break down use case diagrams into 4 different elements: systems, actors, use cases, and relationships. Let's start with systems. A system is whatever you're developing. It could be a website, a software component, a business process, an app, or any number of other things. You represent a system with a rectangle, and you put the name of the system at the top. We're going to build the use case diagram for a very simple banking application. We'll call our system Banking App. This rectangle helps define the scope of this system. Anything within this rectangle happens within the banking app. Anything outside of this rectangle doesn't happen in the banking app. The next element is an actor, which is depicted by this stick figure. An actor is going to be someone or something that uses our system to achieve a goal. That could be a person, an organization, another system, or an external device. So who or what is going to be using our banking app? The most obvious actor is a customer. We are going to have customers that download and use our banking app. Another actor that we'll want in our diagram is the bank. The bank is going to provide information that feeds into our banking app, like transactions and account balances. Here are a couple things to keep in mind when dealing with actors. First, it's important to note that these actors are external objects. They always need to be placed outside of our system. Second, actors need to be thought of as types or categories. For our banking app, an actor isn't going to be a specific individual or a specific organization. We wouldn't label our actors as John and Chase Bank. We want to keep things categorical. So right now we're saying that both customers and banks are going to use our app. And this brings up the topic of primary and secondary actors. A primary actor initiates the use of the system, while a secondary actor is more reactionary. So in our example, which actor is primary and which actor is secondary? The primary actor is customer. The customer is going to initiate the use of our system. They're going to pull out their phone, open up our banking app, and do something with it. Bank, on the other hand, is a secondary actor. The bank is only going to act once the customer does something. If the customer goes on the app to see how much money is in their account, only then does the bank engage with our system to provide the balance. Primary actors should be to the left of the system, and secondary actors should be to the right. This just visually reinforces the fact that customer engages with the banking app and then the bank reacts. The next element is a use case, and this is where you really start to describe what our system does. A use case is depicted with this oval shape, and it represents an action that accomplishes some sort of task within the system. They're going to be placed within the rectangle because they're actions that occur within the banking app. So what is our banking app going to do? We're going to keep things very simple. Our banking app is going to allow a customer to log in, check their account balance, transfer funds between accounts, and make payments towards bills. So if this is what our banking app does, we're going to have use cases that describe each of those actions. We'll have a use case called login, another called check balance, another called transfer funds, and finally make payment. You can see that each of these use cases starts with a verb and reinforces an action that takes place. We also want them to be sufficiently descriptive. If this use case just said transfer, that'd be too vague. Finally, it's good practice to put your use cases in a logical order when possible. That's why we put login at the top. That's the first thing that will happen when a customer uses our banking app. The final element in use case diagrams are relationships. An actor, by definition, is using our system to achieve a goal. So each actor has to interact with at least one of the use cases within our system. In our example, a customer is going to log into our banking app. So we draw a solid line between the actor and the use case to show this relationship. This type of relationship is called an association, and it just signifies a basic communication or interaction. A customer is going to interact with the rest of these use cases as well. They're going to check balance, transfer funds, and make payment, so we'll draw solid lines out to each of those as well. Secondary actors will also have relationships. Remember, each actor has to interact with at least one use case, so which use cases will the bank interact with? When a customer wants to check their balance on the app, the bank is going to provide the correct amount. Let's draw a line between bank and check balance. Similarly, when a customer wants to transfer funds or make a payment, the bank is going to follow through with those transactions. We don't need to draw a line to log in because that process happens within the banking app. There's no need for the bank to actually get involved with the login process. There are 3 other types of relationships in addition to association. There's include, extend, and generalization. Let's build out this diagram with additional use cases in order to explain these types of relationships. When a customer types in their login information, our banking app is going to verify the password before completing the login process. But if the password is incorrect, the banking app is going to display an error message. So let's create 2 new use cases for verify password and display login error. When a customer wants to transfer funds or make a payment, our banking app is going to make sure there's enough money to complete those transactions. So we'll also create another use case called verify sufficient funds. And finally, when a customer wants to make a payment, our banking app is going to give them the option of paying from either their checking account or their savings account. So we'll create 2 more use cases called pay from checking and pay from savings. Let's circle back to this verify password use case and talk about relationships again. How does verify password relate to the rest of the diagram? Neither of our actors are directly initiating this action. It's just immediately going to happen within our banking app every time there's an attempt to log in. This is an include relationship. An include relationship shows dependency between a base use case and an included use case. Every time the base use case is executed, the included use case is executed as well. Another way to think of it is that the base use case requires an included use case in order to be complete. When you have an include relationship, you draw a dashed line with an arrow that points towards the included use case. So in our example, login is the base use case, and verify password is the included use case. Every time a customer logs in, our banking app will automatically verify password. This login use case won't be complete unless verify password is complete. So we draw a dashed line with the arrow pointing towards the included use case, and we write include in double chevrons. The next type of relationship is the extend relationship. An extend relationship has a base use case and an extend use case. When the base use case is executed, the extend use case will happen sometimes, but not every time. The extend use case will only happen if certain criteria are met. Another way to think of it is that you have the option to extend the behavior of the base use case. When you have an extend relationship, you draw a dashed line with an arrow that points towards the base use case. In our example, login is a base use case, and display login error is an extended use case. Our banking app won't display a login error message every time a customer logs in. This will only happen once in a while when a customer accidentally enters an incorrect password. Since this is an extend relationship, we draw a dashed line with an arrow that points to the base use case and write extend between double chevrons. Hopefully, this thoroughly explains the difference between include and extend relationships. But just in case, here's a very basic example to help differentiate between the two. If you sneeze, you will close your eyes. That's an included relationship because it's going to happen every time. Additionally, if you sneeze, you might say excuse me. That's an extended relationship because it supplements the sneeze, but isn't completely necessary in the sneezing process. Just remember that include happens every time, extend happens just sometimes, and don't forget that the arrows point in opposite directions. One quick thing to note is that multiple base use cases can point to the same included or extended use case. For example, both transfer funds and make payment are going to point to verify sufficient funds as an included use case. We want our banking app to make this check every time either of these base use cases occur. You don't need to duplicate the verify sufficient funds use case. The simpler your diagram, the better. The last type of relationship we'll discuss is generalization, also known as inheritance. When you make a payment from our banking app, you can do so from either your checking account or your savings account. In this scenario, make a payment is a general use case, and pay from savings and pay from checking are specialized use cases. You could also use the terms parent and children. Each child shares the common behaviors of the parent, but each child adds something more on its own. To show that this is a generalization, we draw this type of arrow from the children up to the parent. You can have generalizations on use cases like we have here. You can also have generalizations with actors. In certain scenarios, you might want to distinguish between a new customer and a returning customer. You can make them both children to a general customer actor, which would allow you to have certain behaviors or qualities unique to each of these children. One last shape that we'll quickly talk about is a use case with extension points. You can see an example here. The name of the use case is above the line, and then there are extension points below the line. Extension points are just a detailed version of extend relationships. This use case shows that a customer can set up their profile in our banking app. And then these extension points show us that when a customer is setting up their profile, they'll have the option to navigate to a couple different screens. If a customer is confused, they can go to Profile Help. And if they want details regarding their private information, they can go to Privacy Info. Those extension points branch off to extended use cases. Go to Profile Help and show Privacy Info. We can even add a note to show what sort of conditions would lead to these extension points. Now we have a complete use case diagram with various elements that help explain what our banking app does. This is a very basic example, but remember that even complex systems should be restricted to a simplistic visualization of functionality, behavior, and relationships. If you'd like to take a closer look at this example, click on the card in the upper right-hand corner. You'll find this exact banking app example plus several other examples and resources. Thanks for watching this tutorial on UML.
So I think in the discussion, right, you have to download the template and you go to Draw.io. I think you have to download the template here. And you go to Draw.io, so you open it from the My Download. So basically, we have the framework here. You have school registration system, and you have the actor. What is the requirement? Okay, that is, you have to describe the registration process for the first time student in architect. I don't know. Honestly, I do not know what is the process of the registration here. So it's totally up to you. Anyway, you should know about the framework, right? So we should modify and include the relationship and include every action includes the registration here, right? So things like enrollment or ID advising or whatever. Totally up to you. Okay, so in that case, you have the sum of definition. You have the system, you have the actor. In that case, you use case, and you have the relationship. The relationship, you have okay. In the case of the actor, you have a primary actor is the one who initiates the user system, and you have the secondary actor is the one who reacts. Okay. And in this case, it represents action. Some of the tasks in the system, you can have the include. Relationship, you have the extended relationship. So again, I strongly recommend if you watch again if you want more detail. I don't so I honestly I do not have much experience when working this one. Yeah, so I cannot help you much with this one. Now I come back to the this way. Come back to this way. Now we come with a module 2. You work with a debugging exercise. Okay, now again, my suggestion that whenever we work with the zero code, okay, you have to read at the header comment to see what is the purpose of the program, right? This program segment is intended to compute and display the average upgrade of the 3 tests. So basically, for this program, you have the 3 tests of one student, right? Of one student, and you have to find out what is the average of the 3 tests here. Okay, so now see, it break it down in the declaration here, right? And you got the input and you find out the processing and you put it out the output here, right? Okay, now see, if you look at this program, what wrong? What wrong with this program here? What wrong with this program? Yes.
The output at the end is answer instead of average.
Yes, right? Okay, that's the one. The other one. You have the multiple problem is this one. What else?
You have a repetition of test 2 and no test 3.
Yes, right? You need three input variable, test number 1, test number 2, and test number 3, right? That's why when you declare here, you have number test number 1, number test number 2, and you have to modify it here. That test number 3, yeah, right? What else? Yes.
If you calculate the average, you need to have parentheses around test.
Yes, that's the thing, right? So think about this guy here. So you think about in this guy, you think about if you have the 3 tests here, if you have the 3 tests, 70 here, right? And you have the 80 and you have 90 here. So you expect the average is 80, right? Because when you add them up together, you have the 210, and you divide by 3, you have the 240, and you divide by 3, you have 80 here. But what happened with this one? You have average test number 1, you take it out 70. What happened here? Take it out 80 and take it out 90 divided by 3, right? So actually, after this step, you have the 180 for this one, right? Okay, so that's why you have to put everything here inside the parentheses. Okay, this one here. When you figure out average, you want to print it out what's average. So that's why it's not correct. Right? You have to print it out what is average here. Okay, so basically that is very simple program. But again, if you look on this program, it only figured out the average of one student a week, one time a week. Right? That's the difference between this one and the second one. Now, if you look on the second one, the second one here, this serial code segment intend to compute and display average rate of 3 sets from any student. Right? See, that's the problem. That's the thing different here. The program execute until, I see, keep doing it here, right? The program will execute until the user enters the negative value from the first test score, right? So we see when you read in the header command, you have many information you have to pay attention here. Program will execute until user enter negative value from the first test score here. So now it tell you what is the variable who control how to terminate the loop, right? How to exit the loop here. That is the first test score. That's the thing, right? So see, the process here, it works exactly the same as the slide I showed it to you, right? Everything here. You have the declaration, you have the number, you have the test number 1, test number 2, and test number 3 here, right? Break it down in the modular structure here. What is housekeeping? So when we call the module housekeeping, it jumps into housekeeping here, right? Execute here. So the housekeeping, remember, that is a required step in order to run the rest of the program, right? And basically, in the housekeeping, you need to get the value of the variable who control to terminate the loop or not, right? So in that case, see, the first test score here is the one who control how to terminate the loop here. Or whatever you enter, the first test score is negative, you exit the loop, right? That's also I see the housekeeping here. The more important thing is in the housekeeping, you have to get the test number 1 of the first period, right? Okay, but you see, what's wrong with this one? What's wrong with this one here? Yeah, see, for this one here, you only have a prompt, right? You see, if you go back to my slide here, if you go back to the slide, right? See, if you want to get the input, right, you use a combination of both of the prompt and the input, right? So what happened with this one here? What happened with this one? Actually, you have this one the prompt to tell user what he have to do, right? But the thing is that if he enter name is A, you have the action to store the A into the variable name. It's the name here. Makes sense. The same with this one here. Sorry, not this one. Balance here also. If he enters the 1000, this one is only prompt. But you need action to store the 1000 into the variable name balance here. Right? That's why when you come back to the problem here. See, this one you only have the problem with. Right? This one only have a problem with you need action to store it into the what you expected. It's the first test score. That's why you need to put input and test number one. Huh? Makes sense. That is a housekeeping here. So see, once he think about it, the first time he enters the number 70 here. Right? Now you see, you return it to the main program. You move to the next statement in the main program. Right? You check here. If test number one is greater than 0 or not, if you enter the 70, it's correct. Right? That's why what do you have to do with the main loop? Main loop, what's it? Main loop here. Again, enter the test number 2 because you already have the test number 1 here, right? So you don't need to the test number 2, and also you need the test number 3, and you find out what's average, right? So when you done with average, if you want to move to the next student, you need to guess use the test number 1 of the next student here. Make sense? Okay, the process here. And again, this one we have many errors with this one also. I expect that you understand the logic and you have to find out what's wrong with this one.
Is detail loop and main loop the same thing?
The name, it doesn't matter.
It doesn't matter.
Yeah, the name here is only the name of the module. You can put whatever it is, detail loop or main loop or my loop, whatever it is. But you have to consistent when you call it here. Think about this one here, right? So we think about if you put the detail loop here, for this one also you have to change the detail loop, right? Sorry. Okay. Again, it must be consistent with the variable name with the module name. It doesn't matter if you put the detail loop here might be the detail loop. All right. Okay. The same end of job also. You have to be the end of job also. Okay. So this process also. This pseudocode segment is intended to compute and display the cost of home ownership for any number of users. See, any number of users. That means you have to do it for many users here, right? The program ends when user enters 0 or the mortgage payment. So we see, mortgage payment is the one who controls the loop, right? And the one who controls the loop. So you know that the mortgage payment is the one who controls how to terminate the loop. You need to get it from the startup here. Now the name is not the same, right? You see, startup here or get that whatever it is, but you need it here. So startup here, you see, you have the enter 0 for the mortgage payment here, right? So that's why in the startup, you see, you need to get the mortgage payment. Of course, for this one, you have to find out some of the inconsistent variable name. You see, this one is not the same as this one here, right? Okay, so you have to correct it. So now for this one here, you see when you got a mortgage payment, right? So for each of the customer, you have to get the utility, right? You have to get the tax, you have to get the upkeep, and you just add them up together, right? And you print it out. The total is this one here. So what's wrong with this one? What do you think? What's wrong with this program here? If you look on the main loop, what's wrong with it?
There's no input for a mortgage for the second.
Yeah, right. That is very important thing here. Right? See, if you want to move to the next customer, you need to get the mortgage of the next customer here, right? That's why you have to copy everything. You have to copy everything from this one. You move it to the end of this one. That's the process when you get the new mortgage from the next customer in order to run the loop again. Make sense? Okay. Okay, okay, the same of this one here, right? This one. Let me see which one is the better to see. This one or the okay, so this program from user for name and quantity for two product for to program and display the total each user until what's it from user for name. Okay. So for this program here, right? You get the customer name, right? And how much how many item he buy, right? And you find out for each of them is the price 2 bucks here. So we see the process it works exactly the same. Now you see you have the declaration. You see price each 2, that is constant. Right? Always say the 2. That's why you see it put everything in uppercase and put everything at the beginning here. And it has the prompt, and page and message here. So see until you see until and the that is the one who controls the loop, right? The one who controls that is the one who controls the condition of the loop here. So we see, you know, if I now in order to terminate the loop, you need to get the name, right? To get the name, that's why insert. You see, in the housekeeping here, you need to get the name here. And whenever you enter you exit the loop, right? So see, again, you see, that's something wrong here. It's inconsistent module name, right? It's not the variable name, but the module name here. That's the first thing. That's the first thing here. All right. Now. And you see it's a detail loop, right? And you see the detail loop, you already have the name. Now you need to get the quantity and you find the total here, right? And you print out what the name and what's the total here. And again, you see, if you want to run it to the next customer here, right? If you want to run it to the next customer, you need the prompt and you need to store it. You need to get it and to store it in the variable name here, right? That's why something wrong with this here, right? Okay, so basically, you see, it works every same with the mainline logic, right? If you understand the mainline logic, it works exactly the same. It works exactly the same. Now, so basically, done everything in the Python, debugging is okay, router. So what is it? Where's the router program as user for input program? That's number 10. Okay. This one exactly the same with I do on the class. I double the number, but now you do the you time it by 10. That's all, right? And with the graph the program enter the 2 values. So you need to get the 2 number from the user, right? From that you have to find out what is the sum, what's the difference, what's the multiplication of the 2 number. But important thing about this 2 number here, you have to use the echoing input into output, right? So you think about you enter the number 10 here and you have to print out the 10 times of number 10 is 100. You have to specify it, right? And you know what's the process of the echo input already, right? You know that process of echo input already. Okay. So I think this assignment for this week is quite simple. But anyway, if you need any help from me, you feel free to raise to me. Okay. Any question from you? Any question? No, it's quite simple, right? Okay, let me check attendance. So again, that is the way I run the class, right? So basically on Thursday, I spent about 20 or 30 minutes on Tuesday to correct the homework of the last week, and after that I done everything with the lecture, right? And on Thursday again I go with the lecture and I have you to do with the homework assignment of that module. Okay. Yeah, you are here already. And again, if you I recommend that if you need to know more about Raptor or Python, you of course you have engaged in the class, or you can watch it again in my recording. So basically, after this class, I will post a recording on the announcement, and if you need to come back to watch it, or also I upload the slide. You see in the announcement. Then I upload the slide also. And so when you go to the announcement here, when you go to the announcement, no, not this one. Alright, so I always upload a class recording on the announcement. Also upload the slide here. The case if you want to come back and read it for the reference. John, are you here? Here, Jalen, are you here? Anton, are you here?
I'm here.
Who are you?
This is Jalen.
Who are you?
Jalen.
Okay. Eric, are you here?
I'm here. Able to hear me?
Okay. Joe, are you here? Here. Devin, are you here? Lindsay, are you here? Michael, are you here? Matt, are you here? Mallory, are you here? Mallory?
I'm here.
Bill, are you here? Bill? Yeah. Hunter, are you here?
Yep.
Direct, are you here? Direct, are you here? Okay. Marcus, are you here? John, are you here? Who are you? Hello.
John McGoy.
Okay. Paul,
Here,
Paul, are you here?
here.
Adolphe, are you here? Daniel,
I'm here.
Parker, Carl, are you here?
Yes, I'm here. This is Carl.
Yeah, Carl, okay. Alex, are you here?
Here. Alex is here.
Lou, are you here? Tucker, are you here? Tucker, are you here? Luke, here. Okay. Malcolm, are you here? Okay. Okay, so I think that's all for today. Anyway, if you need any help from me, you can stay after the class. You can stay after the class if you need any help from me for the assignment or anything in this class. So I can stop the sharing, but anyway, if you need any help, then stay after the class and raise any questions.